here is a wonderful little word problem for you. Mark is this really rich guy. He has $300. The problem is that Mark has small change. Okay, he only has $5 bills and $10 bills. And we know that he has 39 of them. The question is, how many does he have of each kind? So I highlight the information in this word problem because it's important, okay? And I want to somehow use all this information in setting up my solution. So the first way we start is we need to define, well, what is it that we want to find? And the answer to that is in the question. We want to find out how many $5 bills and $10 bills he has. So those will be our variables. I'm going to say, let's say, let X represent the number of $5 bills, the number of $5 bills, and I'm going to let Y represent the number of $10 bills. And to save some time, I'm just going to copy and paste this here, but instead of X, I'm going to have Y, and instead of 5, I'm going to have $10 bills. So that takes care of what we want to find. Okay, well, I want to find out what X and Y are. Next, we have to set up some equations. So I think the most obvious one is, well, if I have, I don't know, $5 bills and 5 $10 bills, the total number of bills I have, in other words, the physical paper, is 10. Now in this case, the question tells me that Mark has 39 bills in total. So what that means is, if I add the bills he has, forget about their value, I get 39. So this equation here is a relationship between the number of bills. Okay, it's literally you're counting the paper. How many pieces of paper does Mark have in 5s and 10s? Now the second equation relates the value. Okay, if I were to add up the value of all those bills, I am told that it's equal to 300. Well, how do I do that? Well, if I multiply the number of bills of $5 bills by its value, so the number here by its value, which is 5, and then I add the value of a $10 bill, which is 10, by the number of $10 bills, I end up with 300. So this equation here talks about the value of the bills. Okay? The good thing is that we have our two equations, and this is probably the hardest step in doing a problem on linear systems, is that setting up the equations takes some time. Okay, until you get the hang of it, it can be a little bit taxing on the brain, but definitely doable. Now at this point, I mean, these are definitely simple linear systems, no fractions, no brackets, we can solve. And I think the most direct way, based on the first equation I see, would be to solve using substitution. So I'm going to use substitution on the first one, and I'm going to rearrange for x. So I'll have x equals 39 minus y. So what do I do now? I'm going to take this 39 minus y and substitute it for y, not for y, sorry, for x in my second equation. So my second equation will read 5 times 39 minus y, close bracket, plus 10y equals 300. So let's solve for y now. What I'm going to do is I'm going to distribute this 5 into the bracket, over here and over here. This will yield 195 minus 5y plus 10y, which is equal to 300. If I collect like terms, I end up with 5y equals 105, and divide both sides by 5. This gives me y is equal to 21. So my y value is 21. To solve for x, well, I probably will take this simpler equation up here. I have x plus 21 equal to 39. Rearrange for x and I obtain x equals, what do I get? 18. So therefore, to conclude, we can say that Mark has 18 $5 bills and 21 $10 bills. So Mark has 21 $10 bills and he has 18 $5 bills. There you have it. There's your solution to the big cash Mark has.